Hello friends, welcome to Coding Garden with CJ. Welcome to Test-Driven Development, Conway's Game of Life. So I streamed earlier today, but I felt like coding some more, and this is something that I've been wanting to do. But if you're not familiar with it, Conway's Game of Life, it's not a game that you play, but it's known as a cellular automaton. Interesting little thing, if you Google Conway's Game of Life, it actually starts playing the game inside of the browser, which is pretty interesting. Hey Alka, welcome to the stream. So what I want to do is build this game of life, but using test-driven development. So let's check out Conway's Game of Life on Wikipedia. So a cellular automaton is like basically rules for cells and how they spring to life and how they die. So Conway's Game of Life is a zero-player game, meaning that its evolution is determined by its initial state. So whatever the state of all of the cells starts as, that's how the game will evolve and things will show up. So it has a few different rules. The first is any live cell with fewer than 2 live neighbors dies as if by underpopulation. And so the idea is you have a grid. Each cell in the grid represents a cell, like a living cell. And if it has less than 2 neighbors, it disappears and dies. If it has 2 or 3 neighbors, it lives onto the next generation. And any cell with more than 3 neighbors dies because of overpopulation. And any dead cell with exactly 3 live neighbors becomes alive as if by reproduction. So the interesting thing is, like, what we're seeing here is actually an initial state that's being played out. So like each tick of the clock, each next state decides which cells on the board will come to life. So this animation here appears like an animation because each step in the evolution of the state itself is producing these cells that are alive. This is known as a glider gun because each state is producing these things called gliders that just slowly glide to the bottom right of the screen. You may have seen it before, but I have a sticker on my laptop. That's a glider from Conway's Game of Life. So the idea is I'm going to write tests to build this thing out, and the idea of test-driven development is you write a failing test first, then you write code to get it to pass, and then you move on and write another test. And typically you start to refactor as you build out more tests. So that's exactly what I'm going to do. And the thing is, initially, I'm just going to build the game engine itself. We're not gonna actually visualize it. And then after I've built the game engine, we could visualize it with React, or we could visualize it with Vue, or we could visualize it in the terminal or something like that using the game engine that I built. So let's get into it. I am going to set it up with Mocha and Chai for testing. I'll be using Babel, so that way we can use like import syntax and things like that in the tests and in the files that we write, so that if I decide to use React or something like that, it'll play nicely. But basically, I have all of the types of tests here that I want to write. But let's get started. So in here, I need to install all my dependencies. Before I do that, let's set it up as a npm repository. And hello, Nick. Welcome to the stream. So it created my package JSON. It included all of my README as a description, but we'll just say Conway's Game of Life. Let's get all of these dependencies. So we're going to be testing with Mocha and Chai. Mocha is our test runner, and Chai is our expectation library. And then I'm going to install all of these Babel things so we can use like import syntax and stuff like that. We need to npm install those things. Oh, well, they should have been dev dependencies, but stop it. We'll make these dev dependencies. -- save -- dev. There we go. Okay, we have all the things. Next thing is we need to set up Babel. So for that, we need a .babelrc file. And inside of there, we're going to tell it to use this preset env that I added. This is basically the It's a preset that includes all of like the ES Next, ES 2015 features, just in that one preset. So that's our Babel config. And then we'll set up the test directory. So typically when you're testing a project, you have a directory called test. And then inside the directory is where all of your tests will go. So we have the directory. And lastly, we'll set up our test script. So in the package JSON, we're going to update this to be mocha, and we're telling it to use Babel register, so that way we can actually use import syntax inside of our test code. Okay, let's get started. And first, there's a question from Jay. Do you ever do something similar to this README when starting projects? I typically do. If you've seen some of my past videos, I try to create pretty much a to-do list of all the things that we need to do in the app. Often the to-do list will like evolve as we build the app, because we'll find things that maybe we didn't account for. I just went ahead and thought of all of the different tests that I might want to write. Typically with TDD, you might not actually do this. You're coming up with the tests on the fly, but this just helps keep me in line and not rambly while I'm doing this. Okay, so let's start. First thing is we want a cell state. We want to be able to tell whether or not a cell is alive or dead. So let's test that. And the idea with TDD is you always write your tests first. So I'm not going to write any code until I have a broken test for them. So let's create a new file. Let's do like cellstate.test.js. Let's import expect from chai. And we'll need to describe this. So in Mocha, describe is your test suite. So we're going to describe the cell state. And I guess while I'm at it, let me actually create an ESLint file, because right now it's saying describe is not defined. Let's set up ESLint as well. ESLint --init. Let's just use the Airbnb style guide. Airbnb. And you know what? I think later on I will build the UI with React. Right now it's all going to be just tests and just code running, but later I will use React, so I'm going to go ahead and add that to my ESLint. So yes, we use React. JavaScript. No, don't downgrade. Yes, install them. But once I have an ESLint file, I can tell it that like describe and it are global variables that I need. So now we have all of these ESLint things and have an ESLint here. And let's also say, actually we need to add the React plugin. We'll do the React plugin later because we don't need that right now. But we'll say, what was it? Globals. Globals is an object, and describe is a, well, not that. Describe is a global, and then it is also a global. So it should stop complaining about that. Okay, so we have a test suite that is describing the cell state, and we'll put in our first test. So it should have a, let's say, alive state. And here's what we'll do. We'll basically say we'll expect CellState.alive to be 1. So we'll just use like 0 and 1 to determine if it's alive or dead. 0 is dead, 1 is alive. But here's what's going to happen. I'm going to run this code right now. So let's do npm test. And I should get a failing test. That's the idea with test-driven development. You always want to see a failing test first, because now we know that there's something that I need to fix. There's some actual code that I need to write. And the first error I'm getting is CellState is not defined. Well, obviously, because I don't have it in here. So first thing would be, let's import in CellState. Let's grab it from the previous directory and then a file called CellState. If I do this, it should fail because can't find module CellState. So we need now CellState. Let's create a new file, call it cellstate.js. Say, now it exists. Now we run our tests. Expect to be is not a function. Well, I did that wrong. While we're at it though, we can look at the chai documentation, and they tell us all the different things we can use to do expectations. So I'm actually using the BDD style, or behavior-driven development style, with expect. But we can see expect to, we probably want to equal. And I did 2b, so expect to equal 1. Run the tests. Expected undefined to equal 1, because right now SellState doesn't export anything. So I think SellState is going to be super simple. It's just an object. So export an object. We'll say alive has the value 1. Let's take a quick stretch. Cool. Yeah, and Flamingo is asking, are we doing React? We will, but not right now. Eventually, like once we have all of the code passing and like our game engine actually working, then we will build a UI to visualize what's actually happening. So at this point, I should have a passing test, and I do. We're good to go. So now I got to write another test. And hello, Sean from West Coast. Welcome, welcome. So a SellState can be alive. It can also be dead. So I should say it should have a dead state. And then I want to expect that SellState.dead to equal, in this case, we'll just do 0. Failing test, expected undefined to equal 0, because right now, dead is not defined on SellState. So on SellState, we'll also add dead, and we'll make that 0. Okay, so we have passing tests. We can describe the state of a cell. It can be alive or it can be dead. We're on the right track. Let's check some things off in our README. So we've got dependencies, we've set up Babel, we set up our test directory, we added the test script, and right now we have a working cell state. It's either alive or dead. Okay, now we can move on to the cell itself. And like the interesting thing is, like in the description of the rules, it pretty much gives us the tests that we need for a cell. Like we should test a cell for all of these things, and it should have the expected behavior that's described in the rules of the game. So that's pretty much what we want to do. But yeah, let's grab like this first test. So typically with tests, you can split them up into separate files. So I have SellState tests, and then I'm also going to create, let's do a cell test. We're going to import expect from chai, and we will describe it. So describe a cell. And we will say it should be initialized with a cell state. So what I want to be able to do is say some cell is a new cell, and then pass in something like, cell state dot alive. And then once I've created a state, created a cell, I should be able to say, let's expect cell.state to equal cellState.alive, because if I initialized it with alive, it should be alive. What's this complaining about? Oh, extra space. Okay, let's run our tests. First error, cell is not defined, obviously, because I got to create it. So in this folder, new file, let's call it cell.js. And in our test, we'll import it in. No, not destructured, but import cell from cell. Okay. Cell state is not defined, so in the test file, I also need to bring in cell state. So import cell state from cell state. Okay. Cell.default is not a constructor. So right now, cell is a totally empty file. So first we need to actually create something in it. So I'm going to just create a class. So I'll do export default class cell. And let's just do that. So we have a cell. It should at least pass that. And now we get a little bit further. It's saying expected undefined to equal 1. And this is on line 9 of our tests. So on line 9, it's saying cell.state is undefined, but we expect it to be alive. So our code is describing that when we create an instance of a cell, we're passing in a cell state, and it should actually create like an instance property called state that has that value. So here's what we'll do. Cell needs a constructor that takes in something like the state. And then we'll say this dot state equals state. So that will create an instance property. If we test it, our test passed. So cell should be initialized with the cell state. Let's also test that if we initialize it with dead, it also is dead. Dead. Let's call this dead cell and alive cell. Okay, so we can create cells that are either alive or dead. And yeah, so Payman said, have a couple of questions from the Node.js lead stream. Yeah, definitely. And Christian mentioned, so if you check out the Discord, I can help you, other people can help you. Definitely join the Discord and ask in there. I think there's a link to the Discord in the description. You have to fill out a short survey, but you'll get an invite to the Discord. And hello, Christian, welcome. So we've got some pretty basic tests right now. We have a cell state. Cell state is either alive or dead. We can create a cell. A cell can either be alive or dead. So let's see what else. Now we can get into the actual like rules of the game. So a cell should die if it has fewer than 2 live neighbors. So let's do this. So we have a new test. We'll say it should die if it has fewer than 2 live neighbors. So what I have here is we pretty much want some sort of method on the cell to be able to say, okay, hey cell, if you were to have this many neighbors, are you alive or are you dead? Like in your next state. So I should be able to do something like, so what's the test is should die if it has fewer than 2 live neighbors. So if we create a cell that is initially alive, and then we say next state will be, well, let's just call this cell. We'll say cell dot get next state, and fewer than 2. So if I just pass in 1, is it 2 or less? I might need a clarification of the rules, but if we pass in 1, so if a cell only has 1 neighbor, its next state should be dead. So we should expect that next state of the cell to equal CellState.dead. So we create a cell that's alive. We ask the cell, if you only have 1 neighbor, please give me what your next state would be. And then we make sure that that next state would be dead. Let's double check our logic. Let me look at the rules. So any live cell with fewer than 2 live neighbors dies as if by underpopulation. So fewer than 2, I would think that's not inclusive of 2. Yeah, any cell with 2 or 3 live neighbors lives on to the next generation. So we'll handle that in a separate test. But right now, in a live cell, if we ask it for the next state, should say that it's dead if it only has 1 neighbor. Let's try it. Okay, first off, get next state is not a function. So let's create it on the cell. So this is an instance of a cell that has a get next state method. So get next state takes in like number of neighbors. And let's see what this gives us. So right now, expected undefined to equal 0. So right now, get next state is not returning anything. Well, I'm expecting it to equal 0. So let's just return 0. I think it's complaining about my unused variable right now. Yes, but we'll fix that in a moment. Now, technically, I have passing tests, but one of the key parts of test-driven development is after you have passing tests, you typically want to refactor to make sure that like your code handles all cases and is cleanly written. But the thing is, the moment I start to write more tests for this, it's going to fail because now when I start to check if it's alive with 2 or 3, it's always going to be returning 0. So we're going to need to update that. Hey, Oliver. Yes, another stream. Yeah. Okay, so I'm going to leave it as is because our tests are passing, but let's describe do our next test, and this should make us or like require us to actually update our code. So it should live with 2 or 3 live neighbors. So if I create a cell that is initially alive, and then I say get next state, but I pass in 2 neighbors, we should expect that next state to equal SellState.alive. So if it has 2 neighbors, it should be alive. And then similarly, we'll have well, let's call this next state with 2 neighbors. And this is next state with 3 neighbors. 3. And if we call get next state with either 2 or 3, it should return alive. So let's test. Okay, expected 0 to equal 1. And that's because right now we're just doing nothing but returning 0. So let's actually write the logic in here. So should die if it has fewer than 2 live neighbors. So let's say if num neighbors is less than 2, should return SellState.dead. And VS Code is being very friendly. The moment I mentioned SellState, it just like immediately imported it. Expected this to be used by class method get next state. Class methods use this. Let's ignore that for now because I do want to create a class. ESLint disable, well, not that. It's class methods use this. Okay. And hello, Briggs. Good to see you as well. Expected to return a value. Okay, but so if neighbors is less than 2, it's dead. Else, we should return SellState.alive. I think this is just complaining because the else is unnecessary, because if it went into the if, it would return dead. Otherwise, it returns alive. So if the number of neighbors is less than 2, it is alive. Let's test it. Working so far. So it should die if it has fewer than 2 neighbors. We're handling that. It should live with 2 or 3 live neighbors. Really, so at this point we have a passing test, so this is where I would refactor. I would actually refactor this. So if number of neighbors is less than 2 and number of neighbors is less, wait. If number of neighbors is less than 2, dead. We could do like an else if. So else if number of neighbors is equal to 2 or number of neighbors is equal to 3, the next state is alive. And then by default, let's just return SellState.dead. Or we could do this. I think I like that better because it's more explicit. So if number of neighbors is 2 or 3, it's alive. Otherwise, it dies. Okay, our next tests will probably make it better. Oliver's asking, would you consider making an array of test input, expected test output to be bad design? What do you mean by that? So like actually in our tests. Oh, so I guess are you saying instead of doing like a 2 equal, we could do like a deep equal on an array of the 2 things that we're expecting? Clarify if that's what you mean. Okay, so it dies if it has fewer than 2 neighbors. It lives with 2 or 3 neighbors. It dies with more than 3 neighbors. So let's add that test. Should die with more than 3 neighbors. Should die with more than 3 neighbors. And so if we create a cell that is alive and say next state with more than 3 neighbors, and so let's pass in like 4 neighbors, we should expect that next state with more than 3 neighbors to equal SellState.dead. So it should die if it has more than 3. Oh, yeah, so I think that's what Oliver is mentioning. I don't know if I would want to do that, because I do like to be explicit about like testing it with each thing. But I think what Oliver is describing is you could say like expected. Let's take a quick stretch. Hey, Jimmy, welcome back. Yeah, we could say expected is an array that has cell get next state with 2, cell get next state with 3, and let's like actually just comment this out. And we would expected to deep equal an array with CellState.alive and CellState.alive. Need a trailing comma there. So technically this tests the same thing because it's testing the output of the 2 function calls. I don't know if I'd consider this bad practice. I kind of prefer this one because it is more explicit, and like I have these variable names that describe how we're testing it. Because right now, like JavaScript is a language where like the arguments here aren't very clear as to what we're passing in there. So in this case, it might not be clear that 2 is number of neighbors and 3 is number of neighbors. We do have it in the description. With this way, your variable explicitly describes like how you're calling it. Okay, and so I guess what Oliver is mentioning is separate tests for each states and then having an array. So maybe even like deeper than this. So like expected is, well, not expected. Yeah, so this would be CellState alive, like this. I think this is what Oliver is describing. And then now we would deep equal 1, 1, 1, 1. Wait. Oh, I see. So instead of, okay, we could write it like this, and then we could map over it and say expected.map. I guess what should I call these? Results. And then we'll write it on a new line here, but I can say expect results at 0 to equal results at 1. He wants that. Airbnb says just do that. This says now that it's on one line, I don't need parentheses anymore. Interesting. This should still work. It does the same thing. I don't know. I really don't know, Oliver. I right now I'm leaning more towards this one, just because it's very explicit. And I think the thing is you want your test to be as simple as possible, because like if you made a simple error like in creating your map, now your tests have like logic in them themselves. At the same time, it's like a simple map. I don't know. I think that's another code opinion. We were talking about code opinions earlier. Okay, this should still pass. Cool. So should die with more than 3 neighbors. But let's test it. Actually, so we tested it with 4 neighbors. What if we tested it with 5 neighbors? Next state with, let's just say next state with 4 neighbors. and next state with 5 neighbors should be dead. Cool. So we're accounting for 1 neighbor, 2 neighbor, 3 neighbor, 4 neighbor, 5 neighbor. Up here, we didn't account for 0 neighbors. So let's say next state with 1 neighbor. And then we also have next state with 0 neighbors. And it should be dead. Okay. Now, should come alive with exactly 3 neighbors. I guess one thing we're not testing, though, is if a cell was dead, should it remain dead? Well, maybe we'll see that in this next test. So we'll say it should come alive with exactly 3 neighbors. So we create a cell that is initially dead, and if we pass it in and ask for the next state with 3 neighbors, so create a cell that is dead, ask for the next state with 3 neighbors, and then we should expect that it comes to life. Alive. Should fail. It didn't fail. Oh, sorry, this should be... Interesting. So we create a dead cell. We say get next state with... Oh, wait. I guess we have that. Should live with 2 or 3 live neighbors. Should come alive with exactly 3 neighbors. Ah, okay. So our tests are passing, but it's like, it's fishy that it's passing because we should actually be looking at our current state. So if the state is alive, so if it's currently alive and it has 2 or 3 neighbors, then it should remain alive, otherwise it should become dead. Else, if it's not alive, if the number of neighbors is equal to 3, then it should come alive. Otherwise, it dies. Actually, I guess this can be like a more simpler else if. Like that. So if we're alive and the number of neighbors is 2 or 3, come alive. If we're dead and the number of neighbors is 3, then we're alive, otherwise we're dead. Yeah, and yeah, I think Oliver, it's totally up to opinion. I think I'm of the opinion that I like to be explicit. This is, I mean, technically this is a little bit less code because we are like mapping over it. Like one thing you could do is maybe have some sort of like test utility library that you use in all of your projects where you have like an expect map and you pass it an array like this and it does it automatically. And then you could test your util library to make sure that it does what it expects to do. But like you're testing the tests. I don't know. Christian makes a good point. For 2 neighbors, just return the current value. So yes, good point. Because, well, if we're alive and we have 2 or 3, then we should just, we should stay alive. So return its current state. Okay. If we're dead, so this else statement will only happen if the cell state is dead. So if we're dead and the number of neighbors is 3, come alive. Otherwise, we die. Test still pass. Curious how we can be a little bit more explicit with this. Well, let's actually test that though. So should die with more than 3 neighbors. Should die if it has fewer than 2 live neighbors. I'll say something like it should stay dead. Should stay dead if it has fewer than 2 live neighbors. Am I spelling neighbors right? Yeah. And this will test our logic to make sure that, okay, I have a cell that is initially dead. And then basically do all of these tests again, but it should remain dead. So let's see if we have any errors. Still passes, so that's good. So if you create a cell that's dead and you get its next state with 0 or 1 neighbors, it stays dead. Should live with 2 or 3 neighbors. Should die with more than 3 neighbors. Let's do another one that's it should stay dead with more than 3 neighbors. So similarly, we'll create initially a dead cell and then test it with 4 and 5 neighbors, and it should remain dead. Okay, cool. And then should come alive with exactly 3 neighbors. If it was dead, it comes alive. And we're actually already testing that if it was alive and it has 3 neighbors, it stays alive. I think this is good. We're pretty much handling all of the cases. So, but let's actually like read the rules, the official rules. So any live cell with fewer than 2 live neighbors dies if by underpopulation. So we're testing that here. Fewer than 2 live cells, if it was alive, it's dead. If it was dead, it stays dead. Any live cell with 2 or 3 live neighbors lives on to the next generation. So live 2 or 3 lives on. Any live cell with more than 3 living neighbors dies as if by overpopulation. So if it was alive and it had 4 neighbors, it's dead. If it was alive and it had 5 neighbors, it's dead. If it was dead and it has 4, it should stay dead. It should have 5, it should stay dead, etc. And any dead cell with exactly 3 living neighbors becomes live as if by reproduction. So we create a dead cell, 3 neighbors, it comes alive. I think we're handling all of our test cases. I think we're good. So like the interesting thing about this is we can't visualize this yet. We just have we have this cell class, we have this SellState. Next we'll like actually create the game logic, but still we're not actually visualizing anything. We're just testing it with tests. Still passing? Still passing. All right, so let's move on to game logic. It should be initialized with a given state. So I guess the idea is you want to be able to create a game that like has a state like that. Where like basically you give it a grid of alive and dead cells. And then we can test, like if we ask for the next state, what is the new grid and is it what we expect it to be? So first, let's create some tests for the game. Game.test.js. So let's import expect from chai, and we will describe the game. Describe the game of life. And it should be initialized with a given state. Cool. There's a comment from Oliver. If you marked up your functions with their input values, you could check that your tests check all states too, but that seems excessive. So like the tests, like the description itself would have input values? I think I get what you're saying. Like basically, if all of our tests described what our inputs were, then we would be sure that we're testing for all possible cases. Okay, So should be initialized with a given state. So I should be able to create a game and then pass in a state. Let's say like an array of arrays. So we'll have something like SellState dot. Actually, we'll destructure this. So we'll have like alive. Let's just start off with like a grid of like 5 by 5. Cool. I mean, really, the main thing is testing 3 by 3, I believe, because this one cell, its neighbors are considered anything surrounding it. So I think we'll start there. We'll start with like a 3 by 3 state that we're going to be testing up. So let's do that for now. So let's do like 3 by 3 and should be initialized with a given state. So let's actually do this. We'll put the state in a variable. That. And then let's just expect game.state to deep equal or no. So actually what we want is we give it some states and I had a gamepad here. This should be game. The game should actually iterate over it and create cells for every location. So let's say state is there, and then like our cell state should actually be like a new cell with dead. Visual Studio is being too helpful. So it's going to be the duty of the game to basically iterate over the state we give it and create cells with all of those states. Okay, so we initialize a game with a state of cell states, and it should actually create cells with all of those states. Let's see what happens. Okay, so first, dead is not defined, so we need to import dead from SellState. Okay. And then game is not defined, so we need a game. We'll just go ahead and export default class game. And then we need to import it now that we've created it. Let's close out these other things for now. So let's import game from game. Okay, cell is not defined, but we'll need to also import cell. Okay, expected undefined to deeply equal that array. So that's happening here. So right now, game.state is not getting anything. So what we need to do is in our game, we have a constructor that takes in a state, and it sets its state equal to basically iterating over that object and creating cell instances for every cell state in that array. We could, basically we need to iterate over this array of arrays. We could do a map. So let's do state.map. That's going to give us each individual row. And then for each row, we need to map that and create, we're going to get a cell state, and we want to create a new cell with that cell state. Okay, That's a lot of code all on one line, but that should create an array of arrays with cells inside of it of the given state. Let's try it. There we go. So given this array of arrays of states, we then create multiple cells that all have those given states. Awesome. Okay. Should retrieve a cell at a given row and column. So basically, it should retrieve a cell at a given row and column. So I want to be able to create a game. Let's make this a global variable so we can reuse it with something like DeadState. And so if we create a game with the DeadState, and we say the cell will be game.getCell at 0, 0, we should get back a cell that is dead. So expect cell.state to equal we actually should be able to do DeadState at 0 at 0. I guess we also want to check, so expect cell to, I think, can we check if it's an instance of a class? Let's just search the Chai documentation for like instance of. Yeah, so to be an instance of cell. So let's expect cell to be an instance of cell. We're also already bringing cell in here. Okay, run the tests. Get cell is not a function. Oliver did mention they threw something in the Discord. Let's check it out. Okay, so this was for like creating a bunch of different states and checking it. So our test cases are that if a cell is alive and has 0 neighbors, it should die. If it's alive and it has 1 neighbor, it should die. I mean, I actually do kind of like this because this is testing every possible number of neighbors. I think you want to test, 3, 6, 7, there's 8 neighbors on a given cell. Interesting, yeah, and then we're actually creating an it for every single one that describes that specific case. I like it. I guess the thing about it though is it's just so automated, right? It's like we're not writing in. I guess this lends itself less to test-driven development because it's just testing all the possible cases. I'm going to throw this in my code though because I like it because it'll make sure that what I have actually is working. So if we go back to SellState. Cell. So we're doing that there, and then let's do all of these tests here. Let's do it. We're gonna need a bunch of tests. It's gonna be great. So here we go. So should result in CellState.dead when currently CellState.dead with 0 neighbors. So and our test passed for all of those, so that's good. My thought about this is it lends itself less to test-driven development. I guess if we were doing a test-driven style, we would be adding test cases one at a time. But my other thought is like this itself should be in like a test utility library that itself is tested. I like it though. Just gonna leave it commented out for now, but it's good stuff. Okay, so right now, game.getCell is not a function, so let's make it a cell. Make it a function. GetCell. We pass in row and column. And then expected undefined to be an instance of a cell. So we're not returning a cell. So let's just return a new cell. It's technically working. Oh, has a next state. What was that? The test? Oh, you coded directly in Discord and got something. That's fine. Let's make this happen though. So to get a specific cell with a row and column, we should return like this dot state at that given row and at that given column. Should still pass. But let's test it even further. So if we instead we don't initialize it with the game state, and we initialize it with, I don't know, alive, alive. So alive, dead, dead, alive. And let's put this in a variable like game state. That. We'll pass in game state. We want new game.getCell at 0, 0 to be, let's call this like a live cell. Expect a live cell to be an instance of a cell. And expect a live cell.state to equal game state at 0, 0. And we could test the others, but right now alive is not in here. We need to also pull it in from SellState. But let's test it a little bit further. So let's make this the dead cell that's at 1, 1. And so if we get the cell at 1, 1, it should be an instance of a cell, and its state should be dead, or what we initially called in the game state. Okay. So we can initialize a game with a bunch of states. Now comes the actual gameplay. So if we ask it for the next state, do we get the expected state? Oh, I guess even before gameplay, get the number of alive neighbors for a given cell. So let's do this. So in our games, we need another test. So it should get the number of alive neighbors for a given cell. And let's test it with like a very basic game state. So game state will be an array. We have alive. Actually, let's actually do a 3 by 3. So alive, dead, alive. And then we'll do dead, alive, dead, and then alive, dead, alive. So basically, if we say how many neighbors are alive for this given cell, it should give us back 1, 2, 3, 4. It should give us back 4. If we ask how many are alive for this given cell, it should give us back 3. 1, 2, 3. If we ask how many are alive for this cell, it should just give us back 1. So we'll be handling the edge cases. Let's do that in a separate test though. So we'll have one test that checks something that's like inside the grid that's surrounded by neighbors, and then we'll create another test to test something on the edge, because it'll be a little bit trickier logic. So if we create a game and pass in the game state, and then we say game.get number, get number of alive neighbors for the cell at 1, 1. So 0, 1, 1, 2. Yeah, 1, 1. So we're going to be grabbing that specific cell. And we should expect, so actually it should be number of neighbors. We should expect that number of neighbors to equal 4. This is number of alive neighbors. Okay, actually, let's make everything alive. So in like the base case, if everything is alive, it should equal 8. Run the tests. Oh, good question, Oliver. Are we doing a wrapping game of life? So like, is the neighbor of this cell the neighbors over here? I think I'm gonna do one with dead edges. So the moment something reaches the edge, it doesn't have any neighbors on that side, basically. Yeah, so think of it as just, it's surrounded by dead cells. It would be interesting to make it like wrap around. I think I'm gonna do dead cells though. I am. Torus life? What is that? Should I Google it? Oh. A surface of revolution generated by revolving a circle in 3 dimensions. Interesting. That would be super interesting to do like a game of life that's like happening on a surface like this. Whoa. Okay. Our tests are failing right now. Right now, get number of alive neighbors is not a function. So let's add that in game. So game, get number of alive neighbors for row and column should return 8. Test. Right now it's passing because we have a very dumb test that's just returning 8. But let's test it again, but be a little bit trickier. So let's say like this one's dead and this one's dead. So, well, yeah, let's do this. So this one's dead, 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 dead. Should get the number of alive neighbors for a given cell. Let's say get the number of alive neighbors above a given cell. So if we grab this cell, we should at least expect it to have 3 neighbors. And we're just going to write the logic to basically check the row above it. Okay. So in here, we get the row and the column. We could do this manually. Like we could iterate over, with a loop that goes from the column before us to the column after us. Let's take a quick break. Oh, Christian's saying if we wrap the edges, it becomes a torus. So the wrapping is homomorphic to a torus. Interesting. We're gonna be super explicit. So like top left neighbor. Is going to be this dot state at row -1. And actually, we could even be, let's be super explicit. So let's say like row above is going to be this dot state at row -1. Okay. And top left neighbor will be row above at column -1. Top neighbor, let's get rid of the word neighbor. So top left will be there. Top will be the row above at column, so directly above it. Top right will be row above at column +1. Can someone help out Peeman in the chat? Well, actually, Christian and Oliver, would you like to be moderators? I'm gonna make you moderators. You're moderators. Here you go. Boom. Did I do the right person? There you go. You have no responsibilities, but you're allowed to post links if you want to. Could you post the link to the Discord survey? It should be in the description, but in case anybody can't see it. Cool. So top right will be column above and column above it, or so the row above it, the one to the right. As I mentioned, you have to assume no abilities. You just have the ability to post links if you want to. So really, if it's alive, we can just grab the state of that cell, right? So if we say top left dot state plus top dot state plus top right dot state. This should give us alive, 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 at least for what we're testing right now. Oh, well, on the very last page of the survey is a link to the Discord. You might have missed that. Sorry about that. If you just click through the survey, you don't have to submit it again, but on the very last page is the link to where you can join the Discord. Okay, this should do it. So we grabbed the row above us, we got the cells that are up here, up there, and the state of each one is actually a number because it's 0 or 1, and if it's alive, that should be 1 plus 1 plus 1 should give us 3. Expected nan to equal 3. Oh, no. Are we passing in row and column? So for the game, get number of alive neighbors, we're passing in 1 and 1. 1, 1. And for a given cell, so cool. Payment, hurry up and click that link. But I am going to delete it though, because I don't want anybody just like randomly click the link without doing their survey. That link will disappear in 1 minute. This should be working. Let's do some logging. So if we log the row above, let's see what we get. Oh, state is undefined. So technically this wasn't working. Oh, you know what? I think it actually could be, I can't destructure it like this. I think that's it. Oh, this is not good. Mainly because we had passing tests, but they technically shouldn't have been passing. There we go. So, interesting thing. So in ES 2015 imports and exports, if you have something that exports an object, you cannot destructure it directly. So you have to actually import it and then destructure it. But that's working now, and we need to actually fix our previous test. So, and hopefully, that's a good call, Oliver. I actually never tested it with invalid input. Let's do that. So let's go back to what we had and then actually write the test that makes it fail. So for a cell, should be initialized with a SellState. Let's say something like it should throw an error if initialized with if not initialized with a SellState. So if we create a cell with undefined, we should expect this to throw an error. Let's look at the docs for something for expecting to throw. Expect this function to throw. I wonder if I can do this. Expect. So we have a function, and if we create the cell inside that function to throw, yeah, just to throw. Yeah, I guess that's a good point, Oliver. So I could technically, in my SellState, say like export const alive as 1 and export const dead as 0, and then I could destructure it that way. Let's definitely get this test working though. So it should throw an error if not initialized with a SellState. Test. Oh, expected function to throw an error, and it's not. So now if we look at cell, we'll say if state does not equal SellState.alive or SellState.dead, then we will throw new error, invalid state. Whoa, now I'm getting it everywhere. Should be initialized with the SellState. Oh, that's why. I gotta specify both. There we go. Should be initialized, should throw an error if not initialized with the SellState. So that one actually is throwing an error. But we're getting invalid state when we pass in alive or dead. Yeah, good call. Yeah, I think Hugo caught it. I accidentally didn't do the equal to, but let's see. So we're passing in SellState.alive, and we're expecting it to be alive or dead. Then it's an invalid state. Let's just log what the state is. One. Undefined. Yeah, I like that because we could come up with more states. We could come up with like a zombie state. So Hugo is recommending, so if state in SellState. So if the state is not in SellState, because SellState itself is an object, it's an invalid state. Otherwise, set it. Super tricky though, it's still throwing the error. And so whenever we create a cell here, we're passing in SellState.alive. Oh. That should be okay because SellState has a zero, has a well, it won't be, it actually won't be in. I don't think it'll be in because SellState has properties alive and dead. We're not passing in the string alive or the string dead. We're actually passing in 0, 1. So actually, I don't think in would work. But I mean, let's just to make sure that I'm not crazy. If state does not equal 1 or state does not equal 0, it's an invalid state. What? It's throwing an error. Yeah, it'll check keys. So now, oh, or. Was it really the or? Let's see. My Boolean logic is off. So if state does not equal alive, oh, or doesn't equal dead. Yeah, so it would flip. Okay. If it doesn't equal alive and it doesn't equal dead, then it's an invalid state. That's the one. No, that's not the one. Getting a lot of suggestions, but... Oh, okay. No, that worked. That worked. That worked because now we need to fix this. Now, if we change this is the reason I was trying to get that failing test, because I wanted to be able to do that, which should now fix those tests. There we go. Now we only have one failing test. Okay. I could do what they're recommending though. So in cell, instead of checking both of them, so what if later on we decide that cells can be zombies instead of alive or dead? I guess though technically is a zombie dead? I don't know. But we could do not in SellState.values. I always mess up the simplest Boolean logic, yeah. Object.keys. So if state is not in object.values of SellState. Does the in operator work for an array? That works. But is that actually looking at its what do you call it? Its indices? I'm curious about this. I want to look up the in operator for arrays. Because I would feel that we actually had to do like index of or something like that. Yeah, so I think actually by doing in here, it's checking the array to see if it has the property 0 or 1. That's not necessarily what we want. We actually do want to look at the values. Because for instance, if I change alive to be alive and dead to be like the string dead, yeah, I get invalid states everywhere. But yeah, so okay, Oliver clarified my suspicion. So this will check the array indices. We could do index of. We could do object.values.index of state is equal to -1. So if we can't find that state in any of the states, then it's -1. There we go. That's what we want to do. Or we could do find. I like find. Whoa. 1 is not a function. We have to say find s equals to state. There we go. Index of. I need to just move on. Index is -1. Okay, I'm moving on. Yeah, because find actually accepts a function, not just state. Okay. Here we go. This is where we were. Right now, this is passing because it is returning 3 neighbors, but this one is not passing because it's not returning all 8 neighbors. Let's get a little more fine grained with it. I actually do want to do like, so this one is testing the above. Let's also test, it should get the number of alive neighbors below a given cell. So if we make this alive, 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 it should at least give us back 3 here. And right now, it's going to give us 0. So let's also handle that. So we have the row above. Let's also get the row below. And that's going to be row +1. And we'll say bottom left will be row below at column -1. And then bottom, or the thing directly below me, is going to be row below at column. And then bottom right is going to be row below at column +1. And now we got to add all these things on there. Well, we're going to clean up this code. Part of this will be refactoring, but so top state plus bottom left dot state plus bottom dot state plus bottom right dot state. Okay. So below a given cell is working. Let's create another test for getting the cells to the left of a given cell. I'm going to comment out this one yet, because this one obviously isn't going to work because we're not accounting for all the way around it. It should get the number of alive neighbors next to a given cell. So for instance, if we pass this in and we're checking just like left and right, the things left and right of it, we should get back 2. So if we check the number of alive cells for this one, we should get back 2. That should fail. Expected 0 to equal 2, so right now it's getting back nothing. So we need to check, we're getting row above, row below. Let's get left will be, we'll say this row will be this dot state at row. Left will be this row at column -1. And right will be this row at column +1. Christian mentioned this is going to make edge checks pretty ugly. Probably so. I need to clean it up. Once I get it working for all the way around, I'll clean this up, and then to check if we're at the edge, we'll have some logic. Oliver is saying, I find it outrageous that you're using the values of an enum in a calculation. You mean here? Oh, I see what you mean. Yes. This is another refactor, because right now I'm taking advantage of the fact that alive is 1 and dead is 0. But what if we change that to something else in the future? You're absolutely right. I should actually convert these into, like, if it's alive or if it's dead, it's a 1. Yes. So then we say left.state, and then we also say right.state. So that should pass for that one. It does. And now we're checking all the way around it. So our very last one should give us 8. And it does, because we've basically checked all the way around a given cell. Yeah, and Oliver mentioned if we add zombies, it's all going to break. So let's fix. So we have passing tests. Let's refactor this. So we could do a little better than this. So let's see. Yes, the game of unlife. Yes, how can we refactor this? I feel like we could do some like mapping. Because the other thing is like, okay, now that we're checking all the way around, we need to check if we're at column 0, then don't check to the left of it. And then if we're at column, the end of the number of rows and columns, then don't check to the right of it. If we're at the top, don't check above it. If we're at the bottom, don't check below it. Let's do this. So now, instead of depending on state, let's let's do this. We'll have like state values right now, and this is going to have SellState alive. The value is 1. SellState dead. The value is 0. We need to bring in SellState. Or already, we're not, so import SellState from SellState. And then we could create an array of all of the states and then map them to the state values. So that way, if we do add zombies, we just need to add it to this object. Yeah, so that's what Oliver mentioned. Stick them all in an array and then map and reduce. Yeah, let's do that. So, and then when we reduce it, we'll use the state values to grab whether or not we're going to be adding 0 and 1. So we'll have top left, top right, left, right, bottom left, bottom right. So that has all the values in it, and then we want to, well, we don't have to map it. We can just straight up reduce it. So, well, let me clean this up. And then, so need to return this. Reduced, we're going to get access to the sum, and we will destructure the state off of the given cell. And we need to return sum plus state values at the given state. And it all starts off at 0. I need this in parentheses. What? Why is this complaining? A space is required before object. Oh, okay. There we go. Okay, so we have an array of top left, top right. And then let's do the reduce on that line. And state values has, if it's alive, the value is 1. If it's dead, it has the value 0. And later on, if we add zombie, we can make that however what the given value is. But we'll just have to add it here, and then our reduce will automatically still work. I guess the other thing is, like, now we need to how can we make this better to account for the edges? I think I want to write the test first before we start accounting for edges. Maybe put it all in an array, then reduce, sum it up, that we can check the values all in one place. Yeah. Add a line break before top left. I agree. It was looking a little tricky. Actually, yeah, and then we'll do a new line there, and then that, yeah, that's nice. I guess the thing is we can just put our conditional checks around here. Like if row is 0, then don't check above it. We'll have like an if statement that like makes this undefined, and then we can in here only add it if it's not defined. Let's write the test for it first. So should get the number of alive neighbors for a given cell. It should get the number of alive neighbors for a cell in the top row. So let's make all of these dead. Quick break. So yeah, and then if we get the number of alive neighbors for 0, 1, so what are the alive neighbors for that one in the top row? It should give us back 2. We're going to get like nan right now because we're not accounting for that. Yeah, can't read property 0 of undefined. But let's account for it. So basically, if the row number is 0, then don't check above it. Top row above. But I need the variables. Here's what I'm thinking. I could create like a dummy state, and that's just an object with state is 0. And then if row is equal to 0, then oh, I could create a dummy row where everything is dead. No, it just doesn't count as a neighbor. I think that's the thing. Let's not do for row above. If row is equal to 0, then give it a dead cell. Else, grab the row above it. Yeah? Well, actually, I could, technically, I should just like initialize a cell instance. Let's call this like edge cell. And this is a new cell with SellState.dead. There we go. So if it's in the first row, then everything above it is dead. Works. Good. Yeah. So I changed it all over. I said state is 0. Now I actually create an instance of a cell. Okay. So that's good. Now let's test to the left, like to the first column. It should get the number of alive neighbors for a cell in the first column. So if we grab like 0, 0, this is dead and this is dead. Everything above it is dead. So this should actually only return 1. Should fail right now. Similar error. Yep. So now if column is 0, then we don't want to test the left. So if column is equal to 0, then we'll give it the edge cell, else check it. And then we also don't want to check the top left. So if row is equal to 0 or This is an or, this is not an and. Or cell is equal to 0. This needs to be in parenthesis. That's right, column. So if row is 0 or column is 0, then there is no left. There is no bottom left. There's an extra space there. And there is no left. Try. Cool. Yeah, let's test this with like alive in all the different places. So like this one technically should only have one neighbor still. Actually, let's test it with 0 neighbors because everything is dead around it. Oh no, expected 1 to equal 0. So when the cell is here, it's actually giving us back 1. Okay, so if column is 0, then we don't want to check the left. So if column is 0, it's an edge cell. If column is 0, then we don't want to check top. So here, no, this has got to be an, this has to be an and. So if row equals 0 and, no, there still is no top left, it's an edge cell. I actually want to see, I kind of want to debug like what is getting, technically what is alive? What are we getting that's alive? So let's create an object that has all these properties in it and log it. So go. So top left cell, dead, top, dead. Bottom cell is alive for this very last test. What? That's wrong. That is very wrong. It should be 1, right? What should be 1? Oh, I see. I wanted to test this one, but right now I'm testing 0, 0. So technically it is right because the one below it is alive. I see. I wanted to check 1, 0. I wanted to check that one, and that one should have 0 neighbors. Okay, that was an issue of just testing the wrong cell. Okay. And then now the bottom row. So it should get the number of alive neighbors for a cell in the bottom row. So if we put it there, and we're going to test this one, which will be 0, 1, 2, 1. So 2, 1. And its number of neighbors should be 2. Yeah, good call. Richard found it. I was testing 0, 0 instead of 1, 0. Okay, so now when row is equal to the number of rows, then we don't want to look at anything below it. So let's actually store number of rows and number of columns on the game. So this dot number of rows will be state.length. And this dot number of columns will be state at 0.length. Technically, we should probably be doing some checks to make sure that all of the columns, all of the rows have the same length. I don't know. But when the number of rows equals the current row, when the number of rows minus 1 equals the current row that we're checking, then we don't check whatever is below it. So if row is 0 or column is 0, or row is equal to num rows minus 1, this dot num rows. Hello, Cassandra. Welcome to the stream. Okay. If the row that we're checking is equal to number of rows minus 1, meaning we're on the very bottom row, then we want to give it the edge cell. So same thing with bottom. And bottom right. Yes, and so Andreas is asking, are these tests still valid for grids different than 3x3? They should be, because at this point I'm now taking into account, the tests I have so far were just testing like these edges here, but I'm testing if I tested if column is 0, so that should be just the whole left edge. It could be any height. And then now I'm testing rows is number of rows, so it could be any number of rows. So if it's on the bottom, we don't want to check it. Should work, and it works. Yes, and in the spirit of test, definitely. So I think once I get all of this working, we can throw some tests in there with like 10 by 10, 20 by 20, and it should still work. Okay, so we've tested the top row, the column, and the bottom row. We now need to test the far right column to make sure that it's calculating. Bottom left should not check on row equals 0. So when row is 0, don't check the bottom left. Very good call. So when row is 0, I think we have that. So if row is 0, then bottom left is an edge cell, which is dead. Hopefully I can figure out a way to clean this up too, because this is a lot of logic. So let's now check the far right column. Should get the number of alive neighbors for a cell in the last column. So if I check this, then at 2, 2, that's that one, number of alive neighbors should equal 0. Right now it's undefined. Andrea says 20,000 by 20,000. If someone wants to generate a 20,000 by 20,000, I would be happy to put it in my tests. Basically, we just need an array of arrays, and right now you can put zeros and ones. Yes, and Christian says dry, don't repeat yourself. We are definitely going to clean up this code so that we don't repeat ourselves. We're repeating ourselves a lot. Okay, so now if column is the number of columns, then we don't want to check the top right. So if row equals 0 or column is equal to this dot number of columns minus 1, then it's an edge cell. So that's top right. Right, specifically, we don't want to check if column is equal to this dot num columns minus 1. We'll get the edge cell, else that. So top right, right, and then bottom right. So if we're in the bottom row, or columns equals this number of columns minus 1. Then we don't want to calculate the bottom right. Okay, does it work? It doesn't work. Let's double check my test. So 2, 2 would be 0, 1, 2. That's not what I want. I want 1, 2. I'm testing this one. So for this one, it should have no alive neighbors, and it should check all of the bounds. There we go. Cool. Yeah, I think that's great. Let's try to refactor. So now we have the passing tests. So let's refactor this code because it's really, really ugly and really, really repetitive. What time is it? Okay, I think I want to stream for not more than another hour, but oh, Oliver's saying the bottom left condition is too specific. Let's take a quick stretch. Is it though? Because if we're... Oh yeah, you're right. If the row is 0 and column is 0, then don't check the bottom left. Yeah, you're very right. So definitely if column equals 0 or row equals 0 and column equals 0. Wait. I don't need to check row equals 0. So when is the bottom left dead? Here, bottom left is dead. Here, so that's column 0. But I'm already checking column 0, so I don't need to check row 0 because here, bottom left is not dead. So you're right. I don't need to check row equals 0 there. Okay. Let's try to clean this up. This is so much logic. I don't like it at all. What I just thought of is like, what if we just iterate over the entire state, and then only check things that are within bounds. This would like change all of our logic, because yeah. So this is what I'm thinking. Like this would not be as performant with like really, really large states, but we actually wouldn't have to do any bounds checking because we're only checking our existing state. So like iterate over rows and then iterate over columns. If row and column is a neighbor, add to sum. Then we don't have all of these like extra checks. Let's just see what that looks like really quick. Yeah, and so I think Oliver and Richard, I think I fixed it. So bottom left shouldn't be checking row equals 0. It should just be checking column equals 0. Yeah, because if it's at 0, 0, we're going to account for it. But here's what I'm thinking. So if we do like this dot state dot reduce, well, no, this dot state dot, yeah, reduce. And this gives us the num neighbors and each row. And then we want to return num neighbors plus row.reduce. And this is going to be, should I be reducing? I could just be like, let's just do this with a for each really quick, and then we'll turn it into like a, I can't think that far ahead. So let's say like num neighbors starts off at 0. And if we do this dot state dot rows dot map, or for each, we're not creating an array, that's going to give us each individual row. And then if we map over this dot state dot column, oh no, sorry, rows row dot map, that'll give us each column, not map, for each. That'll give us each column. And now if column, let's call this state row. No, row. This will be row num will be the index. This will be column, and we get column num. So if column num is, so this is what I'm thinking. We could create these nested loops. It's going to iterate over the entire state, but we will just check if the row and column match up to neighbors. So if the column is one before us, then and the row is one before us, then calculate it. So if column number is let's say equal to column minus 1 and row number is equal to row, and let's call this, this is a cell, because column, so we're checking the row and the column. So if column number is equal to column minus 1, that means it's the column before us, and row number is equal to, let's call this cell row. And row number is equal to row minus 1. This is top left. So column minus 1, row minus 1, top left. Else, if but I guess what I'm thinking is, if I write out all these conditions, we can now add it up. We technically could then, instead of iterating over the entire state, we could like splice it to only include the right ones. I don't know. Am I am I thinking too crazily? But yes, so like Oliver says, that's expensive. Nice. It is expensive, but our logic gets a lot easier because I don't have all of these like ternaries. I basically just iterate over the whole thing and find the ones that I need, and that way I don't have to do any edge checks either because I'm only checking inside of the state itself. Should I go this route? Yes, why not? It'll be simple. Like our grids are going to be super small anyways. Okay, so if it's the top left, then we'll say num neighbors plus equal to cell values. I think I have that somewhere. State values. Let's put that up here. State values at cell.state. Okay, so we did top left. Let's do top. So if column number equals column and row number equals row minus 1. It should be a let. Else, if we'll do top right, column number equals to column +1, and row number is equal to row -1. That. And really, we can make this just one big OR. So if this or this or this, then do that. I think this wants to be indented one. Oh, I gotta wrap all these parentheses. So that, that, that. So top neighbors. So if it's column -1, row -1, top left, column row -1 that's right above us. Oliver has, I believe. Whoa, okay, so we filter out any row that's not above us, or below us. So if I is greater than row -1 and I is less than or equal to row +1, this is going to give us all of the cells that are neighbors. I'm going to try to write this out really quick, but I like where you're going with this. So, okay, these are our top neighbors. Else, let's just check left and right. So if column number equals column -1, and row number equals row, or column number equals column +1, row equals row. So this is going to be our next neighbors. And then we need our bottom neighbors. It's going to be very similar to this, but just with +1. So column +1, row +1. Column +1, that's the one immediately below us. And then, wait. No, that should be, sorry. Column -1, row +1. Column, row +1. Column +1, row +1. And this is anything that is below us. Next neighbors, and then this is bottom neighbors. Yeah, that should do it. And then it gets rid of all of this funky logic down here. It's not funky. This is just very explicit. And now we should be able to return num neighbors. Did I do it correctly? No, cannot read property for each of undefined. This dot state dot, oh, sorry, this dot state dot for each. There you go. Hey. So this is potentially expensive, but it prevents us having all of like this ternary logic, and we don't have to check for edge cases because we're only looking at the cells that exist inside. What do you think? Like, is this? Yeah, and then we don't need the edge cell anymore. Let's put this down here. The cool thing, so I'll just say, like, I wrote all this logic and stuff, but the cool thing about this is, because we had all of those tests, we could now go for something that's like way different, and the test still passed, which means we're still calculating it correctly. Any opinions in the chat? Like, how do you feel about this? This versus the very explicit logic of like checking everything and checking if it has like edge cases. I guess the other thing is we could technically clean this up even more. So like all of this becomes like just nested ors. Like that. And then we don't need any else ifs. So basically check, is it any of one of the surrounding neighbors? And if it is, add it up to a number of neighbors. Cool. Oliver says the if conditions are amazingly crazy. I don't disagree, but I also think that our like ternary statements down here are very, I don't know. There's a lot of them. It's a lot of code. Other thoughts? I mean, we could Cassandra says, I like things that have more words. So wait, which one has more words though? So like this stuff, it is more explicit because I'm like top left, top right, bottom left. I just kind of don't like all of these ternaries in checking. We could extract the logic though, so we could say, okay, like these first three are so if above, so cell above, and we pass in row num and column num, and then we could have we could define this function inside of here so it has access to row and column. So cell above, quick stretch, is a function that takes in row num and column num and then just returns that. Really, I want to do something like this. And I can create another function that's like cell below. So like, and then when you read this, it's like more readable. Below. This takes in row num and column num. That. And we do cell below, row num, column num. This will be or. And then we can have another function that's cell next, like next to row num and column num. And it just does these two checks. So then we get a nice readable if statement here. So if cell above or cell next or cell below then it's a neighbor. Christian mentions, as usual, it's something unexpected which takes up most of the time. The thing is, like, this is like the bulk of the logic in the game of life, and I kind of want it to be like fairly explicit so we understand what's going on. Let me see in the Discord. Okay, so if column number is greater than or equal to column minus 1, and column number is less than or equal to column plus 1, and row number is greater than or equal to row minus 1, and row number is less than or equal to row plus 1, and column is not equal to the column number, and row is not equal to the row number. Is this the same if statement? Let's try it. So if this stuff, I think it's complaining about line length, yeah, but let's see. It still works. Wait, so if the column number is greater than or equal to, oh, okay. Well, why do I want greater than? Oh, because I want it in the same column too. I don't know. I like my extremely, it's like I made these functions, but now I have these like this very readable if statement that's like, if it's the cell above, the cell next, or the cell below, then it is a neighbor. I'm gonna stick with this. Can someone potentially create me like a very large grid of alive and dead cells? Let's do this. Let's just test it now with like a really big row. So it should get the number of alive neighbors for a cell in a big grid. So what if I'm just gonna make a really big grid. Okay, so let's say like in this gigantic grid, wait, why is it highlighting that stuff? Oh, when I hover over it, it highlights it. Let's make this one alive, 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 alive. But let's do this. If we reach in and grab that specific cell, is it going to give us back 8? If it does, I think we're looking pretty good. So this is row 0, 1, 2, 3, and column 0, 1, 2, 3, 4, 5. So if we look at 3, 5, we should get back 8 alive neighbors. Yes! So that's cool. So technically it's working. I think we do have one last test, which is should create the next state of the game. So the idea is now that we can check for any given cell what is its next state, we need to create basically a new state based on the existing state of all of the cells. So I think I'll do this, and then I'm going to end the stream because I've been streaming for a while, and this is my second stream of the day, and I got work tomorrow. Okay, should create the next state of the game. So, it. Let's do something like this. So I have a game state. Let's look up some like what we know the next state will be. And oscillator, cool. So if the state starts off with like a vertical line like that, it should just go, the next state should be it horizontal. So let's do the blinker. This is a 5 by 5 grid. 1, 2, 3, 4, 5. 2, 3, 4, 5. Oh, forgot that. Okay, so I have a 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. And we'll say that the middle three, these three, should be alive, alive, alive. And then if I do something like game, so next state should be game.getNextState. And the next state should actually be this. So let's create like expected state. Should be alive, alive, dead, dead. I think that's it. So it's an oscillator of 3. Oh, right. A 3 by 3 would be enough because it doesn't need the outer bound. That's fine. So really, these are actually going to be cells, though. So I actually want to wrap these in like a new cell. But these middle 3 are going to be alive. Alive, alive, alive. So I start off with a state of a vertical line. If I get the next state, it should have those 3 alive here. 3 by 3 would make my test fail if I add in wrapping edges. I'm not going to add in wrapping edges today. Okay, so we should then expect the next state to deep equal the expected state. Okay, run the tests. Failing tests, game.getNextState is not a function. So let's create it. GetNextState. Let's do it. So we really need to, we could do a map of a map. So we can map over state. So this dot state. And this is going to give us each row. And then, oh, sorry, this dot state dot map to give us each row. And then we'll map over each row to give us each cell. And then for each cell, we want to do this. So like, we need to get the next state of the cell. So we need to create a new cell with cell.getNextState with, and then we need to ask the game for this given cell's row and column, how many neighbors does it have? So we also need, this is going to be row number, and this is going to be column number. So with a given cell, create a new cell by getting the next state of that cell with this dot get number of alive neighbors at row number and column number. This is a lot all in one line, but basically for any given cell, we can get what the cell will be in the next generation by getting the current number of alive neighbors and passing that into the cell. This code is all on one line. If this works, it works. We could have written this more verbosely, but the reason this works is you're calculating the next state based on the current state. So you actually don't want to turn cells alive and dead in the existing state. You want to keep them the way they are. And then the next state is if you were to call the next state with everything as it was. So that's basically what this is doing, because when we say get number of alive neighbors, it's the current state. It's not the next state. And really, should we be creating cells? So like my expected state. How about no? Like, yeah, I don't think so. So I think what we should do is we actually should get back like deads and alives, and later on we can have a function on the game that's like game.setState. Because I'm thinking like if we're actually create a UI for this, like we would create the game, give it some initial state, and then when we call getNextState, we don't necessarily want to modify the internal state, or do we? Or do we? Yeah, like let's say we do then. Instead of returning the state, we could just modify the internal state. And that way, if when we're visualizing it, if we're using something like React, we just get access to the game state, and if it changes, the UI changes. So let's do this. Let's say game.nextState, and it should move everything forward in time. And so then if I say game.state, it should actually deep equal this. So now let's call this next state. And we'll just say this dot state is equal to that. It's doing exactly the same thing, but now instead of returning the state, it's just modifying the internal state of the game. Okay. Where are we at in terms of time? 2 hours. But we've done a lot of testing. We've talked about the merits of testing. We've coded things in different ways. Our tests are still passing. I guess what I can try to do before we go is just a very simple visualizer with React. So we have cells. We have a button that says, like we have like an initial state. We have a button that says like go to the next state, and then we should visualize it. We should see the cells like come alive and disappear and whatnot. Let's do it. Okay. I don't know if I want to create a React app because I want to like use this code. Like I basically just want to import this game into a React component and then give it an initial state, put it on my React state, and then use it in the render function. But I don't think I want to create a React app. Let's look into Parcel real quick. Parcel React component. Like how easy would it be to just fire up like a parcel with React? Beginner's guide to set up React project with a parcel. Oliver's mentioning, wouldn't you want it to be immutable for React? Yes, yeah, and I guess, yeah. Because that way I can say game.getNextState and just put that state onto React. Literally, like the game state gets put onto React, and then we can iterate over it and show something different for each cell. So yes, you're right. I don't want to say this dot state. I really just want to return a state, and then we'll do this. Next state equals next state. Should still pass. Yeah. I think that so the thing about it is like we can get into the specifics of React, but I think because this dot state becomes a new array with map, technically it would work even though we're like modifying it internally. But I like this because we could have the game object, and then its state we could actually put on React state. And then when we click a button, we call next state, we take that state and set it on state, and then React should re-render. Yeah. Okay. We've got parcel bundler, parcel and React. We need React and React DOM. We've already got Babel, but we do need to add Babel preset React. Create a component. I would perhaps expect it to return a game object. So it returns a totally new game with a new state. Is that what you mean? like this tutorial. React parcel example, a minimum viable React app with parcel bundler. We've got our index.js. It does all of that. We won't add any style. Well, maybe we will add styles. I don't know. Our babel RC says React app. We need babel preset React app. Is this gonna be easy? I could technically just create a React app and like pull my my game files into it. Parcel React, a minimal React boilerplate with parcel bundler. React DOM, parcel bundler. That should be all I need, right? And then if we look at source, index.html, it's bringing in index.js. Index.js is bringing in all of that. Cool. I think this is all I need. Let's try it. Publish it to npm. Yeah, why not? Why not? Do I have a let me update my README. So we can create a game. Let's create a main like index.js, and it just imports SellState, and game. So yeah, so import SellState from SellState, import cell from cell, import game from game, and export default. I guess what's the best way to do this? Export an object that has SellState, because I kind of messed this up earlier. SellState, cell, and game. But then when I import it in, I'll just need to import like game of life, and I get access to these different classes. Main is index.js. Yeah, I could do create React app and then do like a relative import that goes up a few directories. I want to publish it to npm though. That'll be fun. Let me go ahead and initialize this as a Git repo. Git init. Git ignore node. Cool. Nope. Okay. npm, but wait, what? TDD game of life. So yeah, npm publish. Hopefully nobody's taken that name, TDD game of life. Hey! I think we did it. So npm TDD game of life. There it is. Look at me. I'm on the npm. But now we could create a React app and then install it in. Why not? That way I don't have to go through parcel bundler and all that stuff. Okay, so let's do a create React app with TDD React game of life. Well, I'm not going to TDD this. I'm just going to do it with React. Okay, I want to set a timer. We will be visualizing this in next states within 10 minutes. Go. Okay. We got 10 minutes to do this. So we React game of life. Okay, let's open that up with code. Let's go ahead and clear out all the unnecessary stuff. So let's like delete the logo, gone. App.js, get rid of the logo. App.js, we just have like an H1 that says game of life. Well, Conway's game of life. And then if we yarn start it. Am I going to use an HTML table? I don't think so. I could. I think I'm just going to use divs, like inline block divs with a black outline. And we'll do it like number of rows, number of columns. Yeah. Okay, so in this React app, I need to yarn add TDD game of life. That's so cool. I published a package and we're using it. Okay, so now inside of my app, I need to import TDD game of life from TDD game of life. Okay. And I need to create a game. So let's say, so we've imported it, and then we'll say game and SellState is coming from TDD game of life. And then let's just create, I guess we could do it in the constructor. Game is a new game. But technically I want to pass in an initial state. Let's grab one of our states from over here. Let's do the oscillator. We want to visualize the oscillator. So tests, game tests, this is the oscillator. That, okay. So state on our React app has like cells, and that initially is just going to be game.state. And then when we click a button, it's going to go to the next state. Oliver's saying HTML table is going to be the easiest way. Yeah, like why not? Why not? I honestly feel it's going to be easier to do like rows and columns of divs though. I don't know. But let's do this. So in our UI here, we're going to say state.cells.map. That's going to give us each row. And then inside of that, we want to do row.map, and that's going to give us each cell. And each cell is going to be a table column. Is that a TD? I forgot how tables work. I think it's TD, and let's just put like an X in it for now. And this row should be wrapped in a table row. Ah, go away. And this whole thing should actually be a table. And I don't know, let's see what we get. Dead is not defined, alive is not defined. Oh no. State is not defined. Oh, right, because I need to import SellState. Or get them from SellState. So dead and alive should be coming from SellState. State is not defined because that should be this dot state. Import in body of module reorder to top. That's a linting rule, but that's fine. Like that. Okay, great. I need to wrap that in curly braces, this row map here. Cool. I think that worked. Yeah, we need to give it keys. So table row, and then table column. Okay. And then let's do some like conditional styling. So like, yeah, so we are gonna need a, let's give it row num. That's gonna be the key here. And then this is gonna be column num, and that will be the key here. But we could conditionally give it some, I guess, some style. So first, let's just give this a class of like class name of cell. And let's do this in our app CSS. Let's get rid of everything else. Let's say table should have a width of 80% and a height of 80%. And then cells should have, quick stretch, this dot, yes, I forgot the this dot. Cell should have an outline of 1 pixel solid black. Cool. And they should have a width of, I don't know, 10 pixels and a height of 10 pixels. Let's just get rid of the table width and height now. There we go. So yeah, what if we did like 30 pixels? Awesome. But if we make app a flexbox, justify content center. Cool, but flex direction is row. Oh, sorry, column. Cool. But now it's not obeying the width here. Align items center. There we go. Okay, so for a given cell, if it is alive, the background should be black. So let's do like a style binding here. And background, if cell.state is equal to alive, then black, else white. Yes. Okay. So now we need a button that's going to take us to our next state, and it should flop. So let's create a button below the table. Next state. And then when we click this button, we should say this dot next state. And then we need a next state function. And we should say this dot set state. So we want cells to be equal to game dot next state. Just like that. I think that's it. Cannot read property set state of undefined. We could bind it, or we could make this a property function. Boom! Oh, it broke. Okay, let's go to the console. Validate DOM nesting. TR cannot appear as a child of yeah, I need T-body. That shouldn't be why it's breaking though. But we have table T-body. Oh, I need to reassign the state though. I need to say something like, yeah, let's say next state equals game.nextState. And then really, I mean, I'm technically modifying it, but I need to change my game and say game.state equals next state. Really, I should add a function to the library that it allows you to set the state of the game, but that should do it. There we go. You aren't up. Yeah. And so before, when I was clicking the button, nothing was happening. Okay, awesome. Did anyone create like a big grid that we can visualize? One thing is I do want to visualize. Wait, where are we at in time? Did I really only have one? I think it only took 10 minutes. I don't know. Cool, but we're visualizing it. This is good. I want to visualize a glider though. That's my favorite. So let's do that. Let's create like a larger initial state. Okay, so this should give us like a giant, yeah, that's pretty cool. Get a really big cell. So if I create a glider like right here, doop, 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 like right here, yeah, we should see it make its way down. And also, yeah, we could start it as like a random one. Okay. So we want this to be the glider. So this will be alive. Is that a glider? Yeah, that's a glider. Doop 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 doop. Yay! Oh, that's not good. Well, I guess it is. Like, because of our edge cases, it then turns into a block. That's an interesting thing. The still life, a block, if you ever get one, does not evolve. It just stays there the whole time. That was fun. Let's make a pentadecathlon? No, let's make a toad. So it's a three on top, 3 on bottom. But then this goes away. Whoa. Whoa! Okay, I did it wrong, but this is cool. There's one overhanging here and one overhanging there. Is that how it starts? No, I have an extra hangover. You know what? Let's do this. Let's make it so that when we click a cell, we actually set the state of that cell to be a lot, like we'll flip the state. That way we can just click and like create our own state. So on click, let's say cell.state. So if cell.state is alive, cell.state, I need to do a set state. I can't just, I need to call a function. This dot toggle state with cell. Really, I need to pass in row num and column num. Yeah. And then toggle state, we'll take in row num and column num. And then we'll say this dot set state, we need access to the previous state. And we want to return cells to be previous state dot cells dot map, and that gives us each individual row and row number. And then we'll do row dot map, and that gives us each individual cell and column number. And then so these are shadowing. We need different variable names. Let's call this cell row. Let's call this row, and let's call this column. Okay, so if row num equals row and column num equals column, then we need to update the cell. Otherwise, we need to just return the cell. Return a new cell. Did we bring in cell? We did. So if cell.state is alive, then make it dead, else make it alive. Okay, have we done it? Yes, okay, so now we can create, we can really click anywhere and set the state of that given cell. So this is 1, 2, 3, and then 3 on top of it. Okay, so if we have 1, 2, 3, and then 1, 2, 3, technically this should be a toad. Oh, good call. So technically, I need all of this. So what Oliver is mentioning, I need to take all of the cells, well, the new cells, and set it on game state also. So actually, what we need to do is do this, return an object with cells. Cells are going to be equal to that. And then I actually do need to say game.state equals cells. Okay. Yeah, there's our toad. Hello, Azez, asking what extension is that for showing import sizes? I believe it's named something like import sizes. Extensions, show install extensions. Import cost is what it's called. Display the import and require package size in the editor. I do realize though, this is probably, so if you're using import syntax, this is probably the preferred way to bring in specific things instead of like destructuring it, but technically I do want to do that. Toad. Okay, someone mentioned make a glider collide with a toad. Okay, let's make a toad like down here. And then we'll say there's our glider, and eventually those two should collide. Here we go. Whoa, 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 whoa. Whoa. Disappeared. Cool. That was fun. And if you want to build your own client for this, you can pull it down here. I think there's some things that I definitely want to add though. So maybe I'll put it in the to-do of, not the React one, but of this one. So let's say like to-do. We'll say set state for a cell instead of having to like override it. Game state. So to be able to just pass it an object and it'll override itself internally. I think that's mainly it, but this is pretty cool. I'm excited about this. Let's make some more gliders because gliders are great. And then like one over here. And like, okay, that's good. Do 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 do. And eventually they become static blocks. But what happens if you collide a glider with a block? Whoa, whoa. Cool. All right, I think that's it for me. I've been streaming for a while, multiple times today. This was fun. This is something I've been wanting to do for a while. It was fun to do TDD. It was fun to actually implement Conway's Game of Life. The cool thing about it though is there's a lot of interesting things you could do with just this library that I published. So you could create a view interface for it. You could create like a command line interface where you actually see the Game of Life playing out, just printed out to the console. Because like the library itself is UI agnostic. It doesn't care what UI you use for it. Awesome. I think that's it. Thanks everyone for tuning in. I will definitely push this code up to GitHub. I'll put the link in the description. And yeah, thanks for participating in the chat. Christian, Oliver, you all are great. I'm done. I'm gonna go home. I'm gonna get some sleep. Eat some, I ate a little bit of dinner. I don't know. All right, wherever you are in the world, have a wonderful morning, afternoon, evening, or night. We'll see you next time. Here's this.